Welcome to the video lecture by Dr. Biju Vasudevan for the course Calculus 1 Math 111 for week 11. In this first part of this video, we see the introduction to the chapter 3.5 Local Linear Approximation and Differentials. And we solve some problems, all possible steps from these two topics. In this section, we will see how derivatives can be used to approximate nonlinear functions, just like a function shown on the graph, by appropriate linear functions. Also, up to now, we have been interpreting dy by dx as a single entity representing the derivative. In this section, we will define the quantities dx and dy themselves, thereby allowing us to interpret dy over dx as an actual ratio. This is what we are going to do in this chapter. And we know that if a function f is differentiable at any point x0, then a small part of the graph of f in the locality of the point, if this point is x0, in this locality of the point x0 comma y0 here, the graph takes an appearance of a straight line segment. The figure here illustrates that at several points on the graph of y of x square, how the graph can be approximated in its locality. See, when you superimpose every point, you will see that in the locality of this point, the line segment, when you superimpose it, try your level best. See, the curvy space will be looking like a straight line at this locality, and of course most of the time in this locality, this straight line will be approximately equal to the tangent line of the curve at this particular point. This is called a local linear approximation. That is the function at fx, that is a function that is differentiable at x0 is sometimes said to be locally linear at x0. Here we go. The equation of the tangent line is y minus y0, which is equal to m times x minus x0, isn't it? And we should know what is y. Y is assumed to be f of x, and y0 at x0, f of x will be x0. So when you substitute this equation becomes again y is equal to y0 plus m times x minus x0. Here, when you replace y by f of x and y0 by f of x0, you get this equation, and that is the linear approximation of a function f of x at the given point x0. So when this term del x minus x0 becomes del x, you get this final form. And what is in the case of differentials? Up to now we have interpreted the term dy over dx as a single entity representing the derivative of y with respect to x. The symbols dy and dx, which are called differentials, have no meanings attached to them. Our goal is to define these symbols in such a way that dy over dx can be treated as an actual ratio. To do this, we assume that f is differentiable at the point x0. This is the initial point x0. We can take x0 or x differentiable at the point x, and define dx to be an independent variable that can have any real value, and define dy by the formula dy, which is slope times dx. You can say change in y is equal to change in x times the slope, isn't it? The differentials dy and dx can be viewed as a corresponding rise. This is the rise, and this is the run of the tangent line. Now, It is important to understand the distinction between del y and the differential dy. To see the difference, let us assign the independent variable dx and del x the same value. So assume that they are equal. And then what do you mean by del y now? The del y represents the change in y, change in the curve y that occurs when we start at x and travel along the curve y until we moved from x to x plus del x. So this is it. This is called del y, isn't it? Whereas dy represents the change in y that occurs when we start from x and travel along the tangent line until we reach this end of the x line, x plus x del x. That's the difference. So this is called a rise. Dy is called rise of the tangent line. So to understand the concept clearly, we take an example here. This curve is y is equal to x square and its tangent line has been given here. This tangent line, this slope is nothing but the slope of this tangent line is derivative of the function fx. So we have seen the formula for dy. It is slope times dx, isn't it? So here dy is equal to 2x dx, isn't it? Assume x is 1. This is your x, and del x, this distance, the change in x, del x, and we take both equal. Del x and del dx is equal to 2. So we are here. This is x plus del x, this point, and this line is y is equal to 1. Okay. Okay, now we calculate dy here. Dy is equal to 2 times x is 1, so 2 times 1. Dx is 2, so 2 into 2, it is 4. So dy, the rise of the tangent line, this is dy, which is equal to 4, given here. Now let's see what is del y. Del y, the formula from the fundamental definition of differentiation, we know this is f of x plus del x minus f of x, isn't it? So f of x is x square. So f of x plus del x is x plus del x whole square minus x square. So when you expand this one, x square plus 2 times x into del x plus del x whole square minus x square. So x square and x square we cancel, we get 2x del x plus del x whole square. Substitute the values of them. X is 1 here, so 2 into 1. Del x is 2, so del x is again 2 square, so this is 8. So this is 8. So when x is 3, you will find 8 units here. The del x, this is from here, isn't it? 8, it will be del y is 8, so the point here it will be 3,9. The beauty is when you move in this direction, when x plus del x approaches x, that is when del x approaches 0, both del y and dy will be same. Fine. Now let's move to the exercise set 3.5. Question number 5 and 6. There are 2 problems here and there are many other problems in the textbook. You can solve this kind of problems. Confirm that the stated formula is the local linear approximation. So remember one thing here, after when we are looking for local linear approximation, the formula that we are going to use is f of x is f of x0 plus m times x minus x0, which is from the equation of the tangent line. And when you are looking for dy, the formula for dy is the slope times dx. And when you are looking for del y, the formula is f of x plus del y, x plus del x minus f of x. So let's remember all this one and then solve these problems right now. Problem number 5 or 6. Okay, let's solve both. Problem number 5 is given. So we have to find the tangent line, equation of the tangent line, isn't it? What is the formula? You can remember f of x minus f of x0. You can write y minus y0, no issue at all. M times x minus x0. And m is the derivative of the function. You are given f of x is 1 plus x to the power 15. So f dash of x is 15 power root 15, 1 plus x to the power 14, and when you use chain rule you get 1. Therefore m is, substitute the value of x is 0, given x is 0, so f prime at 0, 15 into 1 plus 0, you get 15 plus 15 into 1 plus 0, you get it's 15. It's 15. M is 15. X0 is given as 0. So what is the equation of the tangent line? This will give you f of x minus f of x0. What is f of x0? If f of x is this one, f of x0 is f of 0, which is 1 plus 0 to the power 15, which is 1, isn't it? So we will write here f of x minus 1 is equal to m is 15 times x minus 0. Obviously we will end up with f of x is equal to 1 plus 15x. So this is the new f of x what we get, isn't it? So this is the given function is approximated to 1 plus 15x. Let's do the same for problem number 66, and then you can try other problems from the textbook. So problem number 6. Problem number 6. What is the function f of x is 1 over 1 under square root 1 minus x. You can write it 1 over 1 minus x to the power half, that is 1 minus x to the power negative half. Okay, from the binomial series we can directly find this one as this one, but it's not our aim. We will use the formula f of x. We remember shortly y minus y0, which is m into x minus x0. We can do that one. Y is the given function. What is y0, which is f of x0? Substitute in the given function. X is 0. So x is 0, 1 minus 0 the power negative half, you are getting 1. And now derivative f prime of x. F prime of differentiate this function, equation number 1. When you differentiate this one, you get negative half to the 1 minus x to the power negative 3 by 2 to negative 1. So no need to simplify, substitute, find m, which is f prime of 0, negative 1 by 2, 1 minus 0 minus 3 by 2 minus 1. So this term is 1, and negative half into negative 1, the answer here it is half. So in the formula from here we come here, y minus y0, what is y0? Y0 is here 1. Y minus 1 is equal to half into x minus 0. So y is equal to this negative sign on the right side, 1 plus half times x. So this is the approximation. So f of x has been approximated to this function, or approximately equal to this function 1 plus half times x. That's the end of. You can solve the other problems in the PowerPoint. These problems are your practice problems. It's the same task you have to check. Now the next question is about confirm that the stated formula is the local linear approximation of f. So okay, we are doing the same task again. The x minus x0 will be considered as del x. That's it, isn't it? Let's take one example, 14 or 15. Okay, let's 16. Let's do with 16. F of x is given, which is sin inverse x over 2. Derivate it, f prime of x differentiate it. You will get 1 over square root of 1 minus x by 2 whole square, and then when you differentiate x by 2 by chain rule, you will get to 1 by 2, isn't it? So derivative will give you this term. You don't need to simplify this one, just substitute the x0 value. Here x0 is 1, therefore the slope m is f of f prime of x0, which is f prime of 1. X value will be 1, isn't it? So when you substitute the value here, the numerator is half square root of 1 minus 1 by 2 whole square. Simplify, use your calculator and check the value. Is it equal to, so this is 1 over 4, 4 minus 1 divided by 4, isn't it? So you get 1 by 2 divided by square root of 3 by 4. So square root of 4 is 2, that can be cancelled with the numerator 2, so you get 1 over root 3. This is your slope. Now the formula for this local linear approximation is tangent line y minus y0, which is m times equal to m times x minus x0, right? Y is the given function, y0, so y is the given function, which is, and y0 is, substitute the y. What is y0? We never found y0 here, so I'll find here y0 is f of x0, f of 1. What is f of x? Which is sin inverse 1 over 2, which is pi over 6. So this is y0 is pi over 6, and the 1 over root 3. This is slope m x minus 1. And now the x minus 1, use this information. X minus 1 has been given as del x, so that is it. Y minus pi over 6 is 1 over root 3 times del x. So y is pi over 6 plus 1 over 3 del x. And obviously, what is y? Y is sin inverse x over 2 is approximately equal to pi by 6 plus 1 over root 3 times del x. This is what given here. That's the answer. Try the other problems from the textbook. Say practice problem. Find the formulas for dy and del y, and you should remember the formula for dy is f prime of x times dx, and the formula for del y is f of x plus del x minus f of x. Let's use it here. This problem we will find dy f. What is this? Is f of x. So f prime of x is y prime, which is 3x square. Therefore dy, the differential del y is equal to f prime. F prime is 3x square and then dx. That's the first answer for dy. And what is del y? Del y, f of x plus, so f of x is f of x is x cube. What will be f of x plus del x? It will be x plus del x whole cube. So you should write here by using this formula here, x plus del x whole cube minus x cube. Use a plus b whole cube formula. What is it? A plus b whole cube. A cubed 3a square b plus 3ab square plus b cube. Simplify this one. X cube plus 3x square del x plus 3x del x square plus del x whole cube minus x cube. So first x cube and last x cube will be cancelled. Rest will be 3x square del x plus 3x del x whole square plus del x whole cube. That is the del y. That is it. And the next column, there are two more problems, and I think okay, let's solve one more problem. There are two problems. This try these two problems yourself. 46 and 46a and b. I'm going for a different problem. 51 or 54. Let me choose simple one. 51, isn't it? What is the question? Use differential dy to approximate del y. To approximate del y, isn't it? When x changes as indicated. So x in the given x is so this is x is 2x plus del x, x plus del x is 2. So what is the difference between these two? That is our del x. Del x is 0.03 and x value in the beginning it is 2. These two information should be remembered. And what we are going to do is to find dy. Dy, the formula for dy is f prime of x times dx. And we assume dx and del x are equal. Dx is nothing but del x. Dx is 0.03. So that is it. So no only thing is the f prime. What is f of x? F of x is the given function, which is 3x minus 2 to the power half. So when you differentiate this term, what do you get? 3x minus 2 to the power negative half. Half times 1 by 2 times 3x minus 2 negative half, isn't it? And then differentiate 3x, you will get 3. So your answer here it is 3 over 2 1 over 3x minus 2 under square root. So this is what our dy. 3 over 2 1 over square root of 3x minus 2 and dx is written here. Now substitute all the values. 3 over 2, x value is 2. This is 2 into 3, 6 minus 2, it's 4 and dx is 0.03. Calculate this one you're using your calculator. You're getting 0.0225. So this is our del y change in. So del y, we are using dy to find del y. Del y is dy, which is 0.0225. That's the end. That's the end of this chapter 3.5, and now we will see 3.6 in the next video. Thank you very much. You can ask your doubts through the comments section, or you can send questions through email, or you can contact me through Blackboard. There are live sessions going on the Blackboard. You can follow Be Live on Blackboard. Thank you very much, students.